I have a function f of x equals 2x plus 1 times x minus 3 squared. And I want to start to determine how much information can I glean from this to graph it without actually using a graphing tool. A couple things I can determine is I want to kind of look at what the general behavior of the graph is. The general behavior of the graph, and that's probably best to determine if I multiply it out. Two x plus 1 times x squared minus 6x plus 9. Multiplying it out, again I like to stack, so I'm going to stack over here. Once I stack and multiply it, that gives me a 2x squared minus 11x plus a 12x plus a 9. Actually, this is a 11x squared and a 2x cubed right there. Looking at that graph, a couple things I can tell right away. One thing I want to look at is something called end behavior. End behavior means that a function like this will basically behave for very large or very small numbers like this first term, an x cubed graph. So I know that this graph then is going to basically look like an x cubed or a 2x cubed. Has a general look like that. I also know that it crosses the y-axis. Well, let's back on up here. Let's find out that there's a behavior there. Let's find out where its zeros are at. Where does it cross the x-axis? And to determine that, I need to look at its factors. Well, one factor is 2x plus 1. Set that equal to 0. So one place it crosses the x-axis or x-intercept is at -1/2. And this other one's at +3. But that 3 has multiplicity of 2. So that helps me further identify this graph a little bit. I have a point at -1/2. Something happens there and something happens at 3. And it's gently going up left to right. I can also determine where its y-intercept is at. If x were 0, what's left is a 9. So f of 0 equals 9. So I know this graph then, something happens up there at 9. That gives me a rough idea of what the graph will look like. The graph starts left to right, goes to this point, crosses back down at that point, then at some point it turns back down, heads towards that. Now that value, x equals 3, what do you notice about its multiplicity? It's even. So therefore the graph is going to touch that and bounce back up. And so there's what my graph basically looks like. It has a basic x cubed graph. Left to right, it comes up, swivels, and continues on. I have two solutions, x equals -1/2 and x equals 3. X equals 1/2 or -1/2 has an odd multiplicity, so the graph goes through that point. X equals 3 has an even multiplicity, so the graph touches it and rebounds. And then I also know that it crosses at 9. We can also look at to kind of idea where its local maximum is at and its local minimum is at. Local minimum is right there at 0. And I can say that this graph is increasing from -infinity up to this point, roughly whatever that may be. It's decreasing from this point down to 0, and it's increasing from 0 up to +infinity. Its domain is all real numbers, and its range is all real numbers. In fact, all cubics have that component.